Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the second part of the lecture number 8. My name is Engineer Jaffar Ali and I'm the instructor for this course. So in this part of lecture, we will be discussing another protocol that is basically used for inter-domain routing. You know that there are two kinds of routing. We have discussed the first kind in the previous classes, the intra-domain routing, and now we are going towards inter-domain routing, in which you are basically connecting different kinds of domains. And the protocol that we will be learning in this class is basically known as BGP, or you can say Border Gateway Protocol. So the story so far is that in the previous classes we have discussed about the routing protocols, and you know that these routing protocols can generate the forwarding table and the basically the routing table, and according to that routing table, the packet will be forwarded to their respective destinations. And there are two kinds of or two styles of routing. The first one is distance vector, and the second one is link state. And the third version, which was hybrid version, that was basically advanced form of this distance vector routing. So mostly some books didn't mention it over here, and it mentioned the EIGRP in this kind of routing. But the issues that we were facing in both of these routing was the scalability. You know that these are basically intra-domain routing protocols that we have discussed till now. So it means that they are not sufficient or effective when it comes to a big network or giant network. So distance vector routing protocols suffer from a count to infinity, and link state routing protocols must flood information to the network. So these were some issues, scalability issues, that we were facing when we were discussing the protocols that we have discussed in the previous classes. So in today's class, in this part we are going towards that how you can make a routing protocol that support large networks. You see that a thing needs to be large, and how to make a routing protocol that supports some business policies. So it is also mentioned that you will be able to find the answers for this as well. So the answer for these is basically the routing hierarchy, and in that we will come to the solution, that is basically the BGP and internal and external both. So let's talk about the brief outline of today's lecture. So the first thing that you should know this basically the routing hierarchies. The first thing that is the flat routing doesn't scale. So you have the major things that you always look is basically the storage, and each node cannot be expected to store multiple routes for every destination. Similarly, it will affect the convergence time increases, and you note that if you have no paths as alternate, you will have to the convergence time will definitely increase, and it will create again the problem for the slow convergence that we have discussed in the previous protocols. Similarly, the total messages count increases as we are talking about the communication. So there should be a kind of scenario where there should be a solution, and that solution is basically known as area hierarchy, and that is why we have divided your big network into AS and further areas actually. So areas is basically, let's revisit that areas are something that you want to divide it in your AS actually, and the more you divide it, the more it will be able to handle it. And you know that the things that are connecting your areas to any other areas basically known as the area routers, and all these area routers are getting connected with backbone areas, or you can say the backbone router. So let's say this is your backbone route areas. This yellow line is region is basically your backbone area, and the router which is, let's say there is a router, let's say there is a router, and this router is connected to all these area border routers. So this router will be termed as backbone router. So this was a thing that we have already discussed in the previous classes, so there is no new thing over here. So you see that this is a kind of area hierarchy, addressing hierarchy, or you can say area hierarchy addressing. So where you have this area 1, this area 2, and this area 3. This area 1 has further 1.1, 1.2, 1.1.2, 1.2.2. Similarly, this area 3 has two further areas, and this area 2 has two big areas, and in this 2 you have further two areas, 2.2.1 and 2.2.2. So you can see that you have divided your areas into sub areas and in sub areas as well. And the result in this basically you can be able to find this optimal path, or you can say the suboptimal path, and you will be able to find these green paths and the red paths. You can see that if you want to start from this point and you want to end at this point, you will have two paths. Either you should go from this path, and either you should follow this path. So this will be the thing. You can see that there are three hops when the red is, and there are two hops when there are greens. So when you are using this path, you will be facing one hop, two hop, and then three hop. And if you are going towards this path, you will having one path and two paths. So this is the thing that is basically supported by this area. And you know that internet structure is a kind of a gigantic network, and it not does not support such kind of small protocols, and there should be some protocol that is basically handling this gigantic network, or this huge network. And uh, the thing that basically resolves this issue is basically you see that IGRP and EGP and IGP. Sorry, the IGP is basically Interior Gateway Protocol, in which we discussed different kinds of protocols: IRIP, OSPF, IGRP, EIGRP. And the next thing that we are going towards is basically EGP, that is Exterior Gateway Protocol. And the only protocol that we will be discussing this EGP is basically BGP, Boundary Gateway Protocol. The most important thing that you will learn slowly and gradually is that the more information you embed into the router, the more difficult, or you can say the more costly it becomes as compared to the computational cost. Where we are talking about the computational cost, it increases when you increase different kinds of information. So the SAS numbers, you know that these are very much important, and these were the things that differentiated IGRP, EIGRP with RAP and OSPF, etc. So you can see that you can have these ASNs number are basically 16-bit values. So it means 2 power 16 gives us 65,536. So you can see that we have these kind of huge AS. You can create this kind of huge networks AS inside of your network. But these from this range to this range, this will be kept as private, not for public use. This will be kept for private, and the remaining will be used for the public. And these are some values that you will be seeing in San Diego and 80. These are, so you can see this example inside this. Let's say this is your area. This is your area, and inside this area you can either use IGP and any protocol IGP that we have already discussed. But outside this network, to connect this AS or this area to this AS or this area, you should be having some kind of exterior gateway routing. So that is where this EGP comes into play. You can see that this is basically connecting different AS. So outside this region, you will be using this EGP, and inside you can use IGP. So IGP is basically used in where the network size is not that much large or huge. And you can see that you have already learned that these protocols RAP and OSPF were not scalable, and there was this only used within a small area. And you know that internet is not basically small area, it is a huge network. So these things will be fail, and these ISPs are not equal actually. That is why these things fails, because these sizes are not equal. Maybe the ISP of the size of this ISP is different from this size, and the different protocols or different routers are used in both of these. So one thing that will be differentiated is routing protocol. So you should have some kind of protocol, and for that you have to divide your ISPs into three part. Tier 1, that is default or globally reachability info, and tier 2 is basically regional, and tier 3 is basically your local which you are using at your home, let's say. So some kind of, you can see that area that you use inside your home is basically your tier 3, and inside you, let's suppose your country, let's say this is Pakistan, so you will be using tier 2, and inside globally, let's say this is Asia and this is connected to the uh, uh, you can say the India, or you can take it China, and these are connected to, let's suppose, Facebook or YouTube or any other server. That is basically again the tier 2, that is placed some kind of in the regional office or regional headquarter of, let's say, Facebook or YouTube server data center, etc. Let's talk about external BGP routing and internal BGP routing. So the first thing that you also have to keep in mind is that which policy you want to use. Either you want to use go with this distance routing, or you can use link state routing. So there is no universal metric. It depends on the policy, that which policy you have to decide. If you want to go with distance filter, you can go with this. If you want to go with this, you can also go with this. And the problem with district routing is that the Ballanford variant may not converge. You know that it has not keeping the record of the different paths. So the thing, or there will be slow convergence. So that is why this things fails actually over here. And the problems with link state vector is that it metric used by the routers is not same. Different routers are using different matrices. So the thing that you should be keeping in mind, that these routers should be having the same matrices if they want to connect, and they should be part of a same AS actually. If you are talking about this IGRP and EIGRP, etc. So that is the thing. And these policies may expose the policies to other AS. You can see that the policies you should that is over here will be displayed over here, because these are sharing the same information and they are in the same network ASs. So that is why these will be sharing the information with each other, but that is not problem for us. The problem is that when this information is shared to the routers that is basically connected to some other AS. Let's say this is router 3 and this is a part of any other AS. So the information will be leaked to that router. That is the thing problem actually with the link state router. So the solution is you have to merge both of these. So you have to apply the distance filter routing, but with a directed path. You cannot show your information to a undirected path, or forward your information to undirected path. And for that you should be finding some solution that is basically distance filter routing with the path. So it has combined the both of these informations and positive, or you can say pros of these routing types, and it will is giving you the solution. So each routing table carries the information of the entire path, and loops are dictated as follows. When the AS, that is autonomous system, get route, check if AS already has a path, it will say yes, and it will reject the route. And if it has no path, it will add it in VSLF, and it routes the route for further information to its neighbors as well. So the advantage of this thing is basically the metrics that are used will be suggested and decided as local, and AS will be choosing the path, not the router. This AS will choose the path, not the devices. This AS will choose the path for the device, and protocols ensure no loops. So this thing will be the advantage for this kind of routing, and this is basically known as BGP, that is border gateway routing protocol. BGP uses this TCP to connect peers, and you know that what is TCP. We have already discussed this TCP in very much detail, and the advantage that it provides, the using of interconnecting this these devices using TCP is basically provides simplicity, and there is no need for periodic refresh. Routes are valid until withdrawn or connection is lost. So there is no need to re-update your router information or routing table every 90 seconds or every 30 seconds, etc. It will automatically update itself whenever it feels some change in the router or the path. And the disadvantage is basically the congestion control. How can you control this kind of routing protocol? And there is poor connection interaction between overhead, or you can say high load. So let's talk about this BGP model. This is basically a hop to hop model. It means that BGP advertises only to the neighbors and only to the routers of its neighbors, and it is consistent with the hop by hop internet paradigm. Paradigm is basically nothing but a hierarchy, or you can say structure. So it will just pass the information to its hop, and that hop will further pass uh, that information to another hop, and that information is passed to another hop, and the thing will go on. And AS1 cannot tell AS2 to route to other AS in a manner different than what AS has chosen. So there is no need. There is a need of source routing for that. So you can see that these AS are different, and these AS are not interfering with each other. AS cannot tell this AS2, while in the other protocols you knew that. If in the previous lectures I have already told you that routers should be having same protocols when they are connected to each other. So this protocol provides this facility that you should not have the same route or the same path to follow. So the policy with this BGP is that it provides the capability to enforce various policies. So you're not bounded to some one policy. You will be able to apply your own policy as well, and they are provided by the configuration department, or you can say the administrative department. So you, if you are part of a organization that is basically the administrative side, so you will be controlling these things. And BGP enforces policies by choosing the paths from multiple alternative or controlling advertisement to these other AS, these autonomous systems. So you can choose multiple paths as per your demand, as per your client requirement. So that is why this BGP is of much importance. And the examples of BGP policies are mentioned over here. You can see that it provides a multi-homing. Yes, we have also discussed what is multi-homing, so that concept will be used here as well. A multi-home AS refuses to act as a transit, so it provides the path limit path advertisement. So there will be uh, less overhead as compared to other techniques. And this multi-homing AS can become transit. Transit means the path. Transit is just a path. So this a multi-home AS can become a transit for some AS. So AS will can also be become a part of path actually. It will not be dealing some administrative tasks. You can also use this AS as a transit, or as just as a path. And AS can favor or disfavor any certain AS for traffic transit for itself from itself. So let's say I do not want any router or any AS router. This is, let's suppose, your boundary router for AS1. So if I do not want, let's say, AS2, and I want to transmit from AS1 to AS3, let's say, and I do not want to use this router, so I can disfavor this router, and I will be choosing another path to go to AS3 instead of using this AS2. I will not follow this path. I will choose some other path that will take me to AS3 actually. So this is the some policies that you can expect from this BGP. And the BGP messages are quite interesting ones. The things that are open, keep alive, notification, and these are theory. It determines the whole timer and interval between keep alive or the update message. Zero interval implies no keep alive. And what is keep alive? It will send the periodically its message to its peers to ensure the connectivity. And if this message is not sent and this message is not received by the routing tables, routers will discard this information or this nodes from its routing table. So this keep alive message will be sent periodically if you want to keep your path, your router as a path in some kind of network. And the last thing, notification, you have to use, you can use this BGP message for an error notification, or you can use this for connection establishment or immediately closeness of any connection. So if your connection is closed immediately, you will also get a notification in this BGP format of this BGP message. So what is the update list of withdrawn routes? What routes are now not in a part of this network currently? Network layer reachability, that how can you list of the reachable prefixes, that where how much nodes or devices or router you can use, you can reach using this kind of network. The path origins, the path attributes like origin, path, matrices, you can also find these as well in the messages of these BGP update messages. And all the prefixes are advertised in the message have same path attributes. So this is the common thing that is common in the different messages. The path prefixes, these path attributes will be the same. The path selection criteria is very much simple. You can either go with any of these. You can also go with the hop count. You can go with the path origin. You can go with the link dynamics. Actually, if you remember, I talked about, let's say there was a node, device A, and it wanted to transmit some data to device B. So there was, let's say, suppose this path, it provided only one hop, but the link, or the dynamics of this link was, let's say, it provided 100 kbps data rate, and there was another link that was providing two hops or three hops, but it was providing 100 mbps of data rate. So obviously you want to have this line, because this is providing you 100 more times of this previous one. So that is why the link dynamics also matter in this protocol, and that is a very good thing. So let's talk about internal and external BGP. So you can see the diagram over here. This is your these things is basically your internal BGP in the AS1 region, and if you want to connect to another AS, you can use external BGP as well. So because of the advantages that is provided by this BGP, you can also use it internally as well as externally. And internally, the same messages as the message format of internal I-BGP is same as I-BGP, and the different rules that you need to be addressed, that you need to be followed, is basically the prefix learned about the I-BGP can be advertised to I-BGP neighbor and vice versa, but the prefix length from I-BGP cannot be advertised to the I-BGP neighbor. So these things cannot provide the information to each other, but this information can be provided to this I-BGP for the external routing. And the reason that is, there is no AS path within the same AS, and thus there is a danger of looping, that your packet will be keep bouncing from this R1 to R2. This is your internal I-BGP, and this is your I-BGP. You can see that this R3 can tell R1 and R2 prefixes from R4. This R3 can tell this R1 and R2 about R4, but this R1 and R2 cannot tell about R4 to this R3. You can see that this R3 can provide information about R1 and R2. R3 can also provide information about R1 and R2 from prefixes as R4, and it can also do the reverse path as well. It can also provide the information about R1 and R2 to R4, and R3 cannot tell the prefixes about R2 from R1. So this information, because you can see that this is not connected over here, so that is why there is no link, and that is why it cannot tell about R3 cannot tell about the R2 prefixes from R1. So R2 can only find these prefixes through a direct connection to R1. If you have a direct connection to R1, that is the only solution that this R2 will be able to find these prefixes values, or prefixes matrices, or anything that it wants to be have. Some important concepts include the area structure, that is basically you know that the internet is basically wide area structure, and it provides the routing driven information, and these information is basically dependent on the economic considerations, that how the customer will react, how the providers will react, how the peers, the link will be reacting, that is the linkages or the links or the paths will react to a certain scenario or certain environment. So that is why these things really matters in terms of economic considerations. You cannot just put a device or a path between two users. You have to take the permission of the customer, you have to take the permission of the providers, and you have to establish a proper quality link. You cannot create a temporary link that will be disturbed with even a single drop of rain. So you cannot have that kind of situation in your network as well. So BGP is actually designed to provide the hierarchy that allows scalability, allow enforcement of policies related to structures, and this policies also includes economic policies as well. And this also provides you the mechanism that which path to follow, path which are scalable, height structures from the neighbors, loops, and these are furthermore information that is provided to you by this BGP as well. So this was all about the second part. This in this class we have discussed about the BGP, that is Border Gateway Protocol, and I hope that you will bring some good questions in the class, because you know that I will be very happy if you ask some good questions, because you know that the more you ask, the more you learn. Thank you very much. I see you in the class. Thank you. Allah Hafiz.